Assalamualaikum and hi everyone. So now we proceed to chapter 2, further transcendental functions. Okay, transcendental functions are the functions that involve of trigonometry, exponential, hyperbolic, inverse trigonometry, inverse hyperbolic and log form. Okay, before we proceed further, let us do a review on graph of trigonometric function, graph of exponential, trigonometric identities. Okay, this one you already used in chapter 1. And then review on graph of f and f inverse. Okay, first graph, we look at graph of y equal to sine x. Okay, you already familiar with this graph. So what we can do is you can plot the value of x, okay, like this, and then you will get what is y. Okay, you look at here, let's say x is negative 2 pi. Okay, negative 2 pi. Remember, pi equal to 3.142. Okay, so 2 pi means that 2 times 3.4142. So you can imagine that where is 2 pi, so you get 6 point something. So 2 pi is here. So negative 2 pi. So negative 2 pi, y is 0. So you get here. Okay, let's say negative pi. You get 0. So here. Okay, this one is negative 3 pi over 2. So here, negative 3 pi over 2. You get 1. Okay, 1 is here, right? And then, negative pi over 2. Okay, this is negative pi over 2. You get negative 1. Okay, and then you get 0, 0 here. Okay, and then, let's say pi over 2. You get 1. Okay, and then pi you get 0. And so on. So you will get this graph. Okay, so when you look at the graph, this graph is symmetric with respect to origin. Okay, this one symmetric with this. Okay, so with respect to origin means that like this. So when you have like this, your symmetry of origin is like this. Okay, let's say this one symmetry is like this. Okay. Okay, look at the sign at the properties is period is 2 pi. Okay, meaning that you see this is the pattern from 0 to 2 pi, and then it repeats again. Okay, like this. So it repeat at 2 pi here. Okay, this is 0 until 2 pi. And then start from here, same, right? Same at 2 pi. So the period is 2 pi. And then domain. Domain is all real number. Okay, domain is x-axis. So you see the value at x-axis is all real number. Start from 0 until above, right? And then range is y axis. Okay, you see here, this is negative 1 and then 1. So the range is negative 1, 1. Okay, and then this one is symmetric with respect to the origin. Now we look at graph y equal to cos x. Okay, for graph y equal to cos x, you look at here when x equal to negative pi, y equal to 1. Okay, negative pi, y equal to 1. So you get this. When x is negative 3 pi over 2, the y is 0. Okay, here. Okay, and then when x negative pi, y is negative 1. This one. Okay, so negative pi over 2, you get 0 here. And then when 0, y equal to 1. Okay, and then pi over 2, get 0. This is pi over 2. Pi, get negative 1. Okay, here. And then 3 pi over 2 get 0. And then 2 pi get 1. Okay, here. So, you can see that the period, okay, we refer the period is, okay, this shape. Okay, from 0 until 2 pi. And then, this is the repeated curve, okay, from 2 pi until 4 pi. So, meaning that the period is 2 pi. This one is 2 pi. Okay, 4 pi minus 2 pi get 2 pi. So, you get the period is 2 pi. And then the domain is all real number. Okay, this is domain. Okay, all real number. And then the range, -1, 1. Okay, start from -1 until 1 here. And then this one is symmetry with respect to y-axis. Okay, the graph here same with this. Okay, so this one we call symmetry at y-axis. Okay, now we look at graph of y equal to tangent x. Okay, first, okay, let's say we try x equal to -2 pi. Here, y is 0. Okay, -2 pi, y is 0. Okay, -7 pi over 4, we get 1. Okay, how to know -7 pi over 4? Okay, you have 1.2. Okay, here. So, you have, okay, here is 0. This one is pi over 4. Sorry, -pi over 4. And then -2 pi over 4. -3 pi over 4. Okay. -4 pi over 4. Okay, this one is -pi over 2. This one is -pi. Okay, and then you have -5 pi over 4. And then -6 pi over 4. And then this one, -7 pi over 4. Okay, so when you look at here, okay, let's say -pi, you get 0. -pi is here. Okay, 0. When x equal to -pi over 2, the answer is infinity. -pi over 2 is here and infinity. Okay, infinity, the graph is like this. Okay, and then we look at the period. Okay, you should know where is the period. Okay, we start from here and then the graph is like this. Okay, and then where is the point that repeat the same pattern here? So it should be here, right? You see, this is same pattern. Okay, same pattern. So period start at pi. So the answer for period is pi. Okay, domain is all real number except pi over 2 plus k pi. Okay, so means that here pi over 2 plus k pi. Okay, here and here. So this is not the domain. Okay, because when you put the value pi over 2, 3 pi over 2, 5 pi over 2, you get infinity here. Okay, 3 pi over 2, so you get infinity. And then the range is all real number. You can see here for x, this is range. You get all real number. Okay, so infinity. So you can get any number. And then symmetry at origin. Okay, when you sketch this one, symmetry at origin, you will get this one. Okay, you can do like this. Okay, the graph like this. So you get this one we call symmetry at origin. Hope you understand how to sketch the graph. Okay, last we want to see graph of y equal to cotangent x. Okay, so -2 pi, you get infinity here. Okay, this is negative 2 pi, so you get infinity. And then negative 7 pi over 4, you get 1. Okay, 7 pi over 4, you get 1. Negative 3 pi over 2, get 0. Negative 5 pi over 4, negative 1. Negative pi is infinity. So when you see the graph, you know that the infinity move to down. Okay. And then for negative 2 pi, move to the up. Okay. And then negative 3 pi over 4, get 1. So here, negative pi over 2, 0. Okay, negative pi over 4, negative 1. And then so on, when 0 get complex infinity. So this one, right? So the graph is this one. So repeated, okay? So same thing for the from 0 to 2 pi. You get the same graph. Now we want to look at the period. Okay, the period, okay, this graph, you have this graph. And then this one. So you see, this is the same pattern. Okay, the repeated one. Repeated graph. So the period is pi. And then domain. Domain, all real number except k pi. K is an integer. So pi to pi is infinity. So pi, 2 pi, 3 pi, and so on is not a domain. Okay, domain all real number except k pi. K is an integer. And then the range. Okay, range is all real number. And then symmetry with respect to origin. Okay, so when we look at here, this graph, same like this. So this one is symmetry at origin. Okay.